Hi everyone, I'm Wande. I am explaining about transformation of variable. Last time, transformation of x. Today, transformation of y. This one is a little more difficult than transformation of x. We are studying linear regression model. So, the relation between x and y is linear. Otherwise, in other words, non-linear relation, then we need to transform variable, variable x or variable y. Additionally, there exists assumption about epsilon, error terms, normal distribution with constant variance. So we have to check that assumption by residual, right? We have studied so far. So it is some difficult thing. Transformation of a variable is difficult thing. Okay, let's see. Transformation of y. For data where assumption about the error are not appropriate, we transform y, or the relation x and y is not linear, then we need to transform y or x. Let's see here. Last time, the relation between x and y is non-linear, like this, or like that, or this. But this shows us the constant range, consistent range x and y. In this range, the data x and y are plotted. So you need to check scatter plot of x and y first before linear regression analysis, okay? But in this case, transformation of y, it is not linear, and the scatter plot x and y show like this: small range, small, large, large, small, something like that. That in that case, we need transform y. Okay, this one is when y is transformed in regression model, the distribution of the residual also, of course, changed. Let's consider graph A, this one, this graph A, B, C, which shows data on household income X, and the vacation expenses Y. This X is income, vacation expenses. Okay, low income, low vacation expense, of course. Large income, higher income, uh, high, large vacation expenses. This relationship we can consider, for example. But here, the range of Y expenses range is also small. There is no option, right? But here, higher income, the range will be wider. Some people expenses a little small, like this. Some people will spend large, big expenses. That shows this graph. For example, this is one of the example, resulting in wider range. In this case, we can consider transform y using square root y or square root y plus 0.375. This is some value, specific value for, say, variance stabilizer, something like that. So you don't have to worry about the 0.375, okay? Square root y or square root y plus a 3.375, the result better, you choose that result. In regression model with x, okay? Graph B shows, for example, data on market entry period x. This one is months or year, something like that. The sales volume, this is sales volume, sales amount of a certain product dealerships. That is when the entry period is short, small, the sales volume is low, right? As the entry period increases like this, the sales volume tends to grow exponentially grow. So the range is here small, the range at here will be big. In this case, it would be advisable to transform y using log y. Instead of y, you use log y or minus 1 over y. This one is better. And consider the model with x. The relation between x and y, like log y versus x. Graph C. Graph C represents a form of data that is opposite to that of graph B, right? Opposite case. For example, the production cost Y, this is production cost Y, during the early stage of product development will be high, and the range is big and varied. Big means varied, okay? Variation is large. But over time, the production costs tend to stabilize. In this case, then transform y using also log y or minus 1 over y, reverse. So other cases, I I don't have any uh, material for that, but I told you it is very difficult, complicated, and graduate level statistics. You will study this kind of one if you want study more deeply. Transforming the response variable y, transformation of y that you want to analyze, this one is you want to analyze, is not trivial task. Determining which variable transformation is appropriate can only be done by repeatedly reviewing the scatter plot of data and the residual plot of linear regression model. Scatter plot of data and also residual plot of linear regression model to identify the most suitable variable transformation. Okay, I only recommend you this kind of not many example, but this kind of through this kind of example. But I want to emphasize, you need to see scatter plot of data and residual plot. Otherwise, your result from linear regression model should not be effective. Okay? Okay, that's it today. See you.